Approximately 13.8 billion years ago, the universe, like a magician revealing its most astonishing trick, unleashed its existence with an act of pure magic, the Big Bang. Imagine this: all matter, all energy, everything that exists and will exist, compressed into an infinitesimal singularity. No stars, no galaxies, no planets or moons, just a point hotter and denser than anything we can conceive. And in an infinitesimal fraction of a second, boom, the great expansion begins. In that moment of explosive creation, the formation of the universe's first fundamental components commenced: quarks and leptons. These subatomic particles, constituting the basis of matter as we know it, emerged from the incredible conditions of heat and density that prevailed. Quarks, in particular, began to join in trios to form protons and neutrons, the building blocks of atoms. Leptons, on the other hand, include electrons, which would eventually orbit these atomic nuclei. This was the start of the cosmic dance that would eventually give rise to stars, galaxies, and planets, to ourselves, and to everything we know in the universe. After the formation of quarks and leptons, the universe began to cool, allowing these subatomic particles to come together to form atoms. Protons and neutrons joined into atomic nuclei, while electrons began to orbit these nuclei, thus forming the first atoms. This process of atom formation, known as nucleosynthesis, lasted about 3 minutes. During this brief period, the first atoms of hydrogen and helium, the lightest and most abundant elements in the universe, were formed. These atoms then joined to form the first molecules, marking the beginning of cosmic chemistry and eventually leading to the formation of stars and galaxies. After the formation of the first molecules, the universe continued to expand and cool, giving rise to large clouds of gas and dust. These clouds, also known as nebulae, began to collapse under their gravity, creating rotating disks of gas and dust. In the center of these disks, pressure and temperature increased to the point where hydrogen atoms began to fuse to form helium, releasing an enormous amount of energy in the process. This phenomenon, known as nuclear fusion, marked the birth of the first stars. Over time, these stars grouped together to form the first galaxies, thereby creating the basic structure of the universe we know today. As galaxies formed and evolved, the oldest stars eventually depleted their hydrogen fuel. These cosmic giants concluded their lives in cataclysmic explosions known as supernovae, scattering the heavy elements they had forged in their cores through the process of nuclear fusion. These elements dispersed into space, enriching the surrounding nebulae with the essential ingredients for life as we know it: carbon, oxygen, nitrogen, and many more. This process of enriching nebulae through supernova is a crucial aspect of stellar evolution and element formation. Stellar remnants, laden with these heavy elements, mix with the gas and dust of nebulae, creating the necessary conditions for the birth of new stars and planets. Over time, these celestial bodies become the homes of complex chemical compounds, including those necessary for life. In this sense, the death of the oldest stars is not an end, but a new beginning, giving rise to the formation of new stellar generations and possibly life in other corners of the universe. As generations of stars are born and perish, the universe continues its relentless expansion, growing larger and cooler with each passing epoch. Within this grand cosmic landscape, gravity continues to sculpt matter into more complex structures. Around newer stars, disks of dust and debris coalesce to form planets, moons, asteroids, and comets, carving out solar systems such as our very own. It's in these planetary systems that the potential for life emerges as complex molecules, perhaps spurred on by the energy of a nearby sun, arrange into the intricate patterns capable of self-replication and evolution. The formations of planets and solar systems are a fascinating spectacle in the vast theater of the universe. As gravity gathers dust and debris around young stars, planets begin to take shape in the rotating disks of material. Some of these planets, in their evolution, acquire the right conditions to harbor life, such as a stable atmosphere and the presence of liquid water. On these worlds, complex molecules can begin to interact and rearrange, giving rise to the possibility of life. Like our own solar system, these planetary systems are a testament to the infinite creativity and diversity of the cosmos, a reminder that we are just a small part of a universe in constant expansion and evolution. The exploration of these planetary systems and the ongoing search for life beyond our own planet is an exciting challenge for modern science. The discovery of exoplanets and the detection of possible signs of life on them push us to question our position in the universe and reflect on the possibility that we are not alone. Furthermore, it allows us to appreciate more deeply the beauty and fragility of our own planet, reminding us of the importance of protecting it. Ultimately, the formation of planets and solar systems is a reflection of the dynamics and majesty of the universe, a spectacle that invites us to explore and understand beyond the limits of our own existence. If you liked the video, don't forget to smash the like button, subscribe, and activate the notification bell.